All right, let's simplify some imaginary numbers. So, as you can see from this table here, we have a variety of I raised to certain exponents. And what I'll find is that I really only need to figure out the first four, and then the pattern will repeat itself with every subsequent row. So, just so we're 100% on where these come from, anything to the first power is itself. So, I to the first power is simply I. And where does I come from? Well, it's the square root of negative 1. If we were to square a square root, the result would be what's inside of that square root, which means that the I to the second power would be negative 1. That's going to fill in our second column. I to the third, using our rules of exponents, I to the third is the same as I squared times I to the first, or in other words, negative 1 times positive I, for a result of negative I. I to the fourth is the same as, let me rezoom here, I to the fourth is the same as I squared times I squared, and I squared was negative 1, which will make I to the fourth positive 1. And because I to the fourth is positive 1, my whole table will reset itself. In other words, I to the fourth times I to the first will get me I to the fifth, and that will give me I, which will lead to I to the sixth being negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, and finally 1. And this pattern would continue. So let's take a look at a problem like this here. I have a multiplication problem. I have I to the 27th power times the square root of negative 100. I want to recommend simplifying this first. Why might I do that? Well, when I take the square root of a negative number, another I is going to show up. So the square root of a negative 100 will be 10I. So I'm multiplying I to the 27th times 10I. But I'm really multiplying I to the 27th times I to the first times 10, which is the same as I to the 28th. I to the 28th times 10. Now, hopefully you recognize that 28 is a multiple of 4, which would place us in the fourth column from our column up top. So I to the 28th would necessarily have to fall in this column here. So I can replace I to the 28th with just regular old 1. So when I simplify this fully, my final answer is 10. Let's look at one more together. Let's look at, say, I to the 57th power. There's a couple ways I can simplify something like I to the 57th power. I can either use the fact that it is nearby a multiple of 4 and count either forward or backward. So I to the 56th would be a positive 1. So moving one more column would move me to make this I. The other way I can do this is using a long division and paying attention to my remainder. So if I take the number 57 and divide it by 4, I will get 1, bring that down, 17, 4, 16. My remainder is 1. Now I don't really care about the 14, but the remainder tells me that I must fit into the first column of my imaginary numbers. So because I have a remainder of 1, I must fit in to this first column, which as we can tell is always I.